Hi there and welcome back. You could regard this particular video as the sister video of the previous one, where we were discussing the updates on MonetDB tables and how these updates were being delayed, not applied immediately, but rather a protocol has been written inside Delta tables, ready to be applied to the actual columns to make these changes permanent and visible for everyone. And this video will only have one particular slide, this slide, and everything else will happen in the MonetDB terminal, because we just replay live in SQL and in mul in the MonetDB client how this delta change management actually is going on. Okay, when you do that, please be aware that there is the need to disable MonetDB's default behavior of applying all such changes like insert, deletes, and updates globally immediately, so that everybody, every user, every application can see that, can see the effects. So when you use the mclient console, the default behavior of the mclient console is to commit immediately and make everything visible immediately. We do not want that. We want the actual behavior of the system, of a live database system, that keeps changes local to the change issuing user until an explicit commit is performed and everything is made visible to everyone. So when you do that, and we will do that in the terminal shortly, when you do that, then make sure to, when you do such experiments, make sure to use the ---- autocommit flag or the \a command inside mclient to temporarily turn this autocommit behavior off, so that you can really see the effects of change management. We will switch over to the terminal momentarily, but what we will do then is to recreate one table of the one version of the ternary table, and then apply these three updates. Okay, so a deletion, insertion, and update, so that we really can see how delta change management deals with each of the three. You can see we are performing a deletion of a particular row, another row is being updated, okay, and then yet another third row is being inserted into the table state. Okay, so when we apply these updates to the ternary table, and the autocommit has been turned off with \a, for example, then this command has to do some work. It has to give us, as the local change issuing user, it has to give us a view of the ternary table that reflects all of these three updates. So when we look at the planning and the execution of this simple, very innocent looking select from where statement on ternary, quite some work has to be done internally. All the recorded updates in the data table and the visibility information has to be applied before we can actually look at the result of this query. And we will see how MonetDB makes sure to really reflect these updates for the local user, while they are invisible still for the global user. Okay, so it's time to switch over to the terminal. There you go. And as you can see, I've already started the MonetDB mclient in its MonetDB SQL mode, so we can talk SQL for the next few minutes. And here you can see that indeed the default behavior of MonetDB is the auto commit on behavior. So all the changes are made visible immediately globally, and that's not what we want. So in a minute we will use the \a command to switch this auto commit mode to off. Okay, but for now let's just recreate the playground ternary table. Recreate the table and then populate with 1000 rows. You can look at some of the rows, at some subset of the rows here, just to see that everything is as we expect. Okay, great. So now is the time. Now we want to apply updates to this table, and of course want to observe how delta table and data change management works. So it's time to switch auto commit off. There you go. Okay, So changes to the ternary table will now be recorded in the protocol tables and in the visibility information, but not immediately affecting the column A, B, and C butts of the ternary table. That's what we want. We want to observe change management. Okay. So let's see how deletion would actually perform internally. So, and to do that, to see that, we would use the explain command. And quite some malcode is being listed here, but only the core of this is really interesting to us. Okay, yes. Okay, so as you can see, what's being done here, that is the A column is being accessed as well as the visibility information. And we already discussed why the A column would be accessed here, because it is needed, its values are needed to evaluate this where predicate here, to select the rows that are going to be deleted. Okay, that's the job of the algebra theta select, to identify those rows. As you know, algebra theta select also has the ability to first apply visibility information. Okay, so that's what we're doing here. This is the visibility but it's being applied to the contents of the A but. So visibility is being applied, and then the selection is being performed, a quality selection regarding the literal value 981. All right. And these would be the OIDs, a but of OIDs of those rows that are going to be deleted. Okay, but no such deletion is correctly carried out, but rather this information is being added to the visibility but, and this is the call that makes sure that this is being done. The SQL delete call will read the information about which rows are going to be deleted, and it will affect the visibility information for the ternary table. All right, nice. You can see that the mal program also writes, determines the number of rows in the deleted rows but, so how many rows are going to be deleted, because this is being output to the user as information like this deletion has affected 42 rows. This is being performed here in the mal program. Okay, so this is what the plan would look like for such an update. We have not performed the update yet, but let's do it right now. Let's do and perform the update. And as we know, only the visibility information is being affected, not the actual updates on the column butts. All right, and we see one affected row. Yes, that's what we expected. This is the key selection predicate, one affected row by this deletion only. Okay. So now onto the update. So how would an update of this one particular row that's still present in the table? We deleted 981, but 982 should still be present, and 982 will be selected to have its C value set to -1. Okay, how would the mal program for this look like? Lots of stuff again. Yeah, all right. So again, we would access the ABUT because predicate evaluation has to happen. We would also access visibility information. All right, visibility information would be applied by the algebra theta select, and it would also apply the selection by the equality predicate 982. So these would be the rows that are affected by the update. All right. Then these algebra projections are going on, or this algebra projection and the algebra project. This would retrieve the rows that are going to be updated and would set the tail value of such rows to -1, to the double value -1. So this would be a but that identifies the affected rows, and it also identifies the new tail value of these affected rows, which would be -1. All right, this is all we need to write the protocol. So we call the SQL update function, which will use the retrieved information to write the protocol for the ternary table. It will write a protocol that the C column is being affected, and it will write this information, the affected rows by the update. And okay, so let's mark it like this. This is the bit that actually carries the values that the new affected rows should carry in their C column. All right. So let's count how many rows have been affected, because it's going to be output, and that's about it. Okay. So no change of the C column butts, but just a protocol written by SQL.update. All right. Time to really perform this update and write the protocols into the delta U butts, the delta update butts. Okay, so last step. Let's do the actual insertion, or let's first look at the plan for the insertion. This is the insertion of a new row, and we expect all three column butts, the A, B, and C butts, to be affected by this. The A butt will receive 1001, the B butt will receive the Han Solo version, the Han Solo string, and the C butt will receive the -2 value. All right, let's see the plan. And the plan is rather straightforward. It will just obtain the column butts that representing the columns A, B, and C here. You see the three SQL append statements in these lines. All of these butts will receive new tail values. Every butt will receive the tail value it has to store. And that's about it. This is a protocol, or SQL append will write a protocol about exactly these insertion information. And yeah, so that's about it. No effect on the column butts yet, but just the protocol. This is the number of rows that are going to be affected. It's probably only one row, right? And yeah. So let's indeed perform this update. One affected row. Okay. So lots of updating going on. Globally invisible yet, but it should be visible for us. We are in this mClient session. We have performed several updates on the ternary table. We certainly expect these updates to be reflected for us. When we now select from the table ternary, then we expect all these updates being performed on the ternary column butts to show us the current state of the ternary table. All right. So as I told you when we were looking at the slides, this is the rather innocent selection query, and it should actually be super efficient to evaluate, but ternary has undergone updates. So it's now time to use the visibility information and the recorded protocol information and to apply that. Okay, so let's see. Yeah, so the query is rather involved here. Okay, so what we can see is that the visibility information for the ternary table is being accessed. The C column is being accessed, which is no surprise because we ask for the C column in the result of this query. But then two further SQL bind operations are being performed. And you see that these operations look quite similar, but they differ in this 2 and the 1 argument at the very end here. All right. The 2 indicates that the SQL bind operation is to retrieve the protocol information from the delta U table. So the delta U update protocol information is being retrieved here and then stored in these 2 butts. All right. The 1 indicates that we are interested in the delta insert, in the delta I information, and this information is being stored in this button. The double values to be inserted in the new butt. All right. And now we've got the visibility information in C5. We've got the delta U information in X13, X14, and the delta I information in X11. All of these are arguments to the SQL delta function, which will actually perform the updating the insertion and the restriction of visibility on the column CBUT. So this is the SQL Delta function that actually performs and reads the protocols and performs the effect. Okay, so I said that C5 would, the visibility information would be passed to SQL Delta. That's not correct. The visibility information is applied later on when SQL Delta has done its job applying the delta I and delta U information. As a last step, as the slide in the last video already showed you, the visibility restriction is being performed by projecting the visibility information on the output of SQL Delta. All right. So delta I, delta U have been applied, visibility information has been applied. Now we see the current state of the C column in this particular case. Here's some preparations are going on to preserve the final result. And yeah, this is then passed to SQL result set, which will provide the output for us. Okay, quite some stuff is going on to make sure that the protocol updates are actually being applied when it's time to do so. So when we perform this query, give the system some time to really do its job, we will see that indeed the row with a value 981 is gone here. It's not to be found in any of the output here. Okay, so the deletion has actually been performed. The update has been performed. This is the sentinel value -1, which stands out between all the logarithm values here. This is the result of the update on the row with a equals 982. And a new row is being added. The new Han Solo row has been added with a value 1001 and C value -2, just as we wanted. Okay, so the protocols and visibility information have been successfully read by SQL Delta and then applied to provide us with the local view of the ternary table that is valid after all these updates. Everybody else will see the original state of the ternary table. Okay. So to dive even deeper, let's replay the whole stuff on the mul level of things. Let's replay the whole thing on the mul level of the game. So before we do that, we just recreate our original table because we have played with it and actually performed updates. I don't want that. I want the original vanilla state of the table again. Now it's in the original state again. It's time to end the SQL session. And it's time to open a new mul session. Okay, this is talking mul now. Okay. Let's prepare talking to the SQL subsystem of MonetDB. All right. And now we try to replay what happens on a delete. And as you recall, the delete, to implement this particular version, this particular delete statement, we would first access visibility information, then the A column information, the A column but to apply the predicate here. All right. Okay, so let's do that. Okay, and let's see and have a look at the deleted rows. Which rows have been affected by this particular deletion? Okay, so it's only one row, and it's the row with OID 980. This is the row that would have the A value 981. All right, because rows OIDs are starting from 0 in this particular case. All right, so this would be the one affected row of the deletion. Okay, and yeah, this has to be recorded in the system. That's why we use the SQL delete call here to write to affect the visibility information for table ternary. All right. Okay, visibility information has been affected. Okay, So that's about it. That's the delete. So now let's do the update. The update again starts with an access to the visibility information. Okay, let's do that. The visibility information in particular should have been affected by the secret delete, in the meantime. So let's just check it. Let's just check it how the visibility information of our ternary table looks in the meantime. Okay, so let's see. There is one row that has been deleted, the 980 OID row, and as you can see, indeed, it's missing. Everybody is here. Every row is visible still, but the 980 entry is missing here. So yeah, this is the correct visibility information after the delete. Indeed, the row is gone. All right. So we are continuing our processing of the update. What we would do now is try to evaluate the predicate on the A column just to see which rows would be affected by the update. Okay, then we would collect the updated, the A values of these updated rows and use that to produce a BUT with all the updated new C values. Okay, and all of the new C values will be -1. Okay, so that's everything we needed to record to represent that particular update. Now it would be time to save this protocol information, the protocol information in updated rows and updated C. So which rows are affected, which is the new C value for these rows, to save this in the delta U delta table or protocol table. And that is the job of SQL update. Oh, unmounted, very interesting. Okay. Okay, so that's the SQL update. Okay, so let's see what actually has been written into this delta U protocol. And that would be the relevant information there, the updated rows and the C values for these rows. Let's print that. And yeah, it's only one row that's affected by the update. It's the row with OID 981. This is the row carrying the A value 982. All right, and the new C value that should be placed there once the update is applied is -1. All right. Okay. So now let's replay what an insert like this would have on the system, on the delta I table in this particular case. So let's evaluate these SQL append statements. All of these affect one of the column butts, but of course not the column butts, but the delta I table for these column butts. Let's do that. Okay, right. So all applied. And that's about the insert. All right. So everything has been saved either in the visibility information or in the data tables. We could, just like the real system, just like the SQL terminal of MonetDB, we could replay in mul the evaluation of this simple select TC from ternary as T command. But as you know, we would have to replay and use all the protocol information to actually compute the current version, the now current version of the ternary table for this user. Okay, so let's do that. We would access the visibility information and access the globally visible version of the C table, of the C column but. Okay. Let's see about the visibility information. This should still show the missing 980. Okay, nice. Okay, the missing 980 is indeed still being recorded here. Let's see what else is there. It records the visibility of something new. This is the effect of the inserts that we've just performed. The insert have prepared the visibility information for the presence of a new row. A new row with OID 1000. We haven't seen that before. This is the new row that is holding these new column values. SQL append has modified the visibility information that to announce that such a new row is now visible for this particular user. This is actually not yet reflected in the C column. This is the original state of the C column, but visible to everyone, and it should not show these particular changes. Okay, there is no row with OID 1000 here. In the global version there is none like this, and there is still the 980 row because it's still visible for everyone but us. Okay, right. So the commands that are being performed now will make sure to apply the protocol and visibility information to this, but to the global visibility C, to restore, to create the locally visible C that reflects all the updates for us. And to do that, we would, of course, access the rows in the delta I and the delta U tables. And this is done with the SQL bind commands using arguments 1 and 2, as I've shown you earlier. Okay, so read the relevant protocol information. Got that. Okay, make sure that the protocol says what we expect it to say. Okay, there's one row to be inserted with OID 1000 and C value -2. Okay. And the updated row is the row 981 with new value, C value -1. So this protocol information would now have to be applied to the original C column, but and this is what the SQL.delta would normally do in MonetDB. Here we are replaying this manually. So first we would apply the update information from the delta U table, and this is done by a but replace. Okay, a but replace would replace rows in the C column but. We would then insert the new information from the delta I but. And then apply visibility information. This is in the ternary but, and it would be applied to C0, to the version of the CBUT that we are currently constructing, the updated version, locally to this user. Visibility information applied. And this column but, this null variable, the CBUT of doubles, this is the new version, the local new version of the C column, and thus the result of our SQL query. Okay, so it would carry a new row with the -2 value here. Okay, this is the appended, the inserted row. It would have one new row here with carrying the -1 value, and one row value would be gone. Okay, so that's not being seen here, but so something that's absent cannot be seen, but you have to trust me, it's indeed gone because we have applied the visibility information. So the update has been performed, the insert has been performed, the as you can see, it's only 1000 rows. Indeed, one row has been deleted, one has been inserted. The one row is actually being deleted. We have locally applied all the updates saved in the visibility and in the delta tables, just as needed. All right. So this concludes this rather longish demo, but we now have a complete picture of updates are actually being handled inside MonetDB using this delta table logic to save global users from suffering the updates that we have applied locally until the next commit, when all these changes would be visible to everyone. All right. So that's about it, actually. That makes a wrap for the chapter 5 about row updates. We have just discussed the PostgreSQL and the MonetDB side of things. This is already the end of this particular discussion, but we will come back to transaction management later on in the course, where the controlled application and visibility of these updates are being managed for all users, concurrent users, parallel users of the system in particular. But it's not that time yet. It's time for chapter 6 in the next batch of videos. And I hope you're staying with us. See you then. Bye-bye.